basically a one-day deal.
Maybe like
40 hours, 36 hours.
That left there?
Yeah. All right, kids. Come on. So, Jaylee, you got 4 years. You and What? I don't have one. I don't have an Apple one.
You can't get good grades in my classes. I have no material. Are you drunk right now? Yeah, she walked in. I was like 5 minutes late. Yeah, you're just like that.
All right, let me have your attention up here. We do still have 2 weeks left in the semester. We still have 2 weeks left in the semester. We got to finish a little bit of chapter 6. We did the first part of it, but there's 2 sections here, 6.5 and 6.6. And then we're going to do a quiz over those. So it looks like the quiz, I believe, is going to just hit on Thursday, but it's only over 2 sections. And then we jump into chapter 7. I think that's the last summative grade of the 9 weeks of the semester. Okay, and then obviously we'll have a few homeworks. You remember, your semester grade or your semester exam does not affect your 9 weeks grade. So for like sports and eligibility and that, your 9 weeks grade is what determines that. And then overall, your final grades at the end of the year, the exam does get put in there. All right, so we're going to go through section 6.5, graph and solve linear inequalities in 2 variables. All right, so at the top there, those that are highlighted should be where you have the blanks. So a linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol. Now remember, an inequality symbol, like that, is less than. Remember, if it's going the other way, it is greater than. And then we got less than or equal to, greater than or equal to. You put the line underneath it, you got the equal to part. Okay. A solution of a linear inequality is any ordered pair that makes the inequality true. Okay. Now, usually for a linear equation, we have a line to determine this. We're going to have a lot more solutions for this inequality. But we do the same idea. So take a look at part A. It says the point is negative 2, 4. Okay. The inequality is y is less than 2x plus 1. Is that a solution? All you do is you plug in those values in for the x and the y and see if it makes it true. Okay, so let's do that. Take out the y. What should go in for it? It should be the 4. Is 4 less than 2 times negative 2 plus 1? And simplify that on that right-hand side. And what does that end up giving? What's 2 times negative 2 plus 1?
Negative 3.
Negative 3. Is 4 less than negative 3? No. So that means this point here is not a solution. It is not a solution. Okay. All right, so the point 4, 5. Y is, and we're using the inequality, y is less than x plus 1. Okay, so we're going to plug in 5 for the y, less than 4 for the x, and then it's x plus 1. So when I simplify it, I get 5 is less than 5. Is that true? No. So again, it is not a solution. It is not a solution. Okay, for that. All right, that's just how you test a single point. Plug it in, just like we always do, see if it works. All right, now, to list all the solutions, we got to graph it. And we're going to go through a little bit of things here. All right, so graph the solution to the linear inequality, y is less than or equal to 2x minus 3. All right, the first thing we need to do is we need to graph it like we normally graph a line. First of all, think of it as the line y equals 2x minus 3. Okay? Remember how we graph that. We did it on the exam. We've done it before we had break. You have a y-intercept of negative 3, of 0, negative 3. We have a slope of 2 or 2 over 1. So go down to negative 3 and put a dot. Now don't connect anything just yet. Let's just make the dots and hold on for a second. So go down to negative 3, make a dot. Go up 2 and to the right 1 because it's a positive slope. And down 2 and to the left 1.
If you remember, we did something somewhat similar when we just did inequalities with one variable. We would have to graph it on a number line. And we'd have either a closed circle or an open circle, and then we'd have to draw an arrow one way or the other. It's the same thing with these linear inequalities. We have some extra work to do in finding our answer and showing what the actual answer is. And that's the graphing part of this.
Right, now I said put the dots on there. Now here's why. You go from there. You either use a solid line or a dotted line based upon the inequality. If your inequality has the equal to part, if it's less than or equal to or greater than or equal to, you use a solid line. If it is less than or greater than, you use a dotted line. Does anybody remember why? Other than because I told you. But there's a reason. Okay, here's the reason. The solid line means that the points on the line actually serve as answers to the inequality. The dotted line, those points do not actually work for the inequality. Okay, they make it kind of like that last one where it's like 5 is less than 5, but they don't actually work. So in this case here, since it's less than or equal to, you need to make this a solid line. Okay, it's a solid line. And make sure you put arrows on it. Now, here's what it does. This line cuts it in half. And either one half works and the other half doesn't work. So like all the answers above the line either work or all the answers below the line don't work, or vice versa. It's not the line itself. That is just kind of a boundary. All right, so here's what you got to do is we got to take our inequality, y is less than or equal to, y is less than or equal to 2x minus 3, and we got to pick a test point and plug that test point in. And if it works, everything that on that side contains the test point is our answer, and everything on the other side isn't. The easiest test point to pick is 0, 0. I'm going to erase this for now because this isn't part of our answer. As long as 0, 0 is not on the line, use that as your test point. Test point is 0, 0. All right, just like you did before, plug it in, see if it makes it true. Plug in 0 for y, plug in 0 for x. And see if that final statement is true. So I get 0 is less than or equal to 2 times 0 minus 3. 0 is less than or equal to negative 3. Well, it's not equal to it, but is 0 less than negative 3? No. 0 is not less than negative 3. So what that means is that any point on this side of the line would not work. It means every point on the other side would work. And then what we do is we shade, you have to shade one side of the line. And so it means everything over here would work. So that is your answer. You have a solid line, and then you shade everything. Make sure you keep shading. Don't. Looks like it stops there. Keep going all the way up to the line. All the way up to the line. All right. What was that? Y is less than or equal to 2x minus 3. Okay. Give me 1 point. Morgan, give me 1 point in that shaded region. One ordered pair.
4, negative 3.
1, 2, 3, 4. 1, 2, 3. 4, negative 3. All right. Now I just want to double check here and make sure we understand what's going on. So negative 3 goes in for y. 4 goes in for x. It says negative 3 is less than or equal to 8 minus 3 is 5. Is negative 3 less than or equal to 5? Yes. So that just kind of confirms, and it doesn't matter which point you pick. Okay, it'll work once you pick one test point. The other test point didn't work. And you only need to do it one time. And once you get it shaded, you're fine. We only did it just to show it for the first one. Okay. Less than or equal to or greater than or equal to solid line. Because these points, we would plug them in, it would actually make it equal to each other. If it's less than or greater than, dotted line. Yeah.
Is there a certain side that we have to shade?
Well, we're getting to that, but we shade either one of the sides has to be shaded in the end.
I'm saying do we have to shade one or the other, or no?
Do
we have to shade the ones that work or the ones that don't?
Shade the ones that work.
Okay.
Shade the ones that work. Okay, I got you now. Yes, and don't shade the ones that don't work. All right, so copy this down. I think what are you missing there? Make sure it's greater than negative 8. Greater than negative 8. All right, before we graph that, we gotta get that y by itself. Which means I gotta subtract 5x. And that gives me 2y is greater than negative 5x minus 8. And now divide each piece by 2. Divide each piece by 2. And I get y is greater than negative 5 halves x minus 4. And just leave that as 5 halves. Don't make it a decimal. We never want to do that with slow. So once you got negative 5 halves x minus 4, we want to graph that. Now, am I going to have a solid line or a dotted line? Okay, solid line or dotted line. It goes with the symbol. Since it is greater than, just the greater than, doesn't have the equal to part. Okay, that means that we are going to use a dotted line. And so I'm going to put the points down here. I'm going to start at negative 4. 1, 2, 3, 4. Put a dot. Negative slope means I got to go up 1, 2, 3, 4, 5 to the left 2. I don't think you have quite as many spots as I do. You can probably only get 2 or 3 points in there. But get those in there, 5/2, and then draw a dotted line. Okay, a dotted line. So it needs to look like this. It means that answer, every point on the line will not be an actual answer. Now I'm going to use y is greater than -5/2 x minus 4. We got to shade one side of the line or the other. All the points on one side will work and all the points on the other side won't. We just got to figure out which side works and which side doesn't. So that's where you pick the test point. And now is 0, 0 in a possible option here? Yep, because it's clearly not on the line. So use test point 0, 0. And now plug in those and I get 0. What do I get here? I get 0 is greater than -4. Is that true or false? Is 0 bigger than -4?
Yes.
Wait.
Yeah. Yes, true. True. So that means that we shade the side that, since it is true, you want to shade that side. So all the way down that line, okay, everything on that side, any point in there will make this true. Every point in there or in that on that side will make it true. Now there is a little bit of a shortcut that you can use so that you don't have to do the test point each time. Anybody remember? There's a little bit of a shortcut. It has to do with the type of inequality and whether you shade above or below the line, because each one you can either shade above or below. All right, now think about this. If you had y is greater than 2x plus 3, and you had to pick, just wait, would you shade above or below the line? If you wanted the point y is greater than 2x plus 3, what is greater than lends you to think? Okay, Josh? Above. If you got greater than or greater than or equal to, you're going to shade above the line. Now look, you only do it though once you get the y by itself. So here, this is, once I got this says y is greater than. Well, did we shade above the line? Yeah. If it's less than or equal to, you're going to shade below the line. The test point will always work, but it's just going to confirm whether you shade above or below. And that's what that thing at the bottom says. Okay, read right here. When the inequality, hold on here. This has to do whether, all right, right here. When the inequality is greater than or equal to the points above the line are solutions of the inequality. When the inequality is less than or equal to, the points below the line will work. But that's only when y is by itself. And then it also tells you when it's going to be solid. If it has the equal to part, it's solid. If it doesn't have the equal to part, it's a dashed line or dotted line. Okay. Can you still do a checkpoint? Yep. But it just sometimes it's a little bit quicker if you don't. So you figure that out. All right, let's take a look here. Flip it over on the back. All right, so for number 3 there. Graph the solution to the inequality. Now, get y by itself. Now, we got to be careful here. Subtract 4x. Make sure you write down that original. And then subtract 4x. And I get -3y is greater than negative 4x plus 12. Alright, Tyler, what do I do from here?
You divide everything by -3.
Alright, good. You divide everything by -3. Now, with inequalities, what happens when we divide by a negative number? You have to do something to the sign. Flip it. So now it becomes less than. And -4 divided by -3 doesn't come out to a whole number, so we're just going to leave it as 4/3 x, but 12 divided by -3 is -4. All right, make sure you have that. If you know how to graph that, go ahead and graph it. If you're not quite sure, just wait. Should I have a solid or dotted line? Dashed. Dashed or dotted? Yes. Okay. If you think you can graph it, go ahead, but then otherwise wait. Okay, so you start at -4, put a dot, 1, 2, 3, 4. And I'm gonna go up 4, 1, 2, 3, 4, to the right 3 since it's a positive slope. And then I'm gonna go down 3, 4, over 3. Now make a dashed line connecting them. A dashed line through those. Okay, so since it's less than, we use a dashed line. All right, should I shade above or below? Yeah, great. I'm sorry. It's been a long Christmas break. Oh, that's what I'm saying. Below the line, because it is less than. All right, now, sometimes there's a confusion. Is it above or below? Below, just put your pencil on the line, and if you draw an arrow straight down, that tells you where it's at. That's below. So everything on that side of that line, we want to shade. And if you pick a test point, that means if you use 0, 0, it should be false, and you should anything on that other side, it should be true. Okay. But I'm hoping you don't have to do a test point. If you understand the above and below, that makes life a little bit easier. Okay, so shade, shade below. All right, the next two can be either really easy or really hard. Hopefully they're on the really easy side. Y is greater than 1. Okay, that's A there. Y is greater than 1. Do you remember how to graph that? That's the hard part right now.
No.
Some of you forget how to graph that. You don't see an X part, do you? There's no slope. This right here is a horizontal line. And it goes through the point 1. And since it's just greater than, it's going to be dotted or dashed. This is what it should look like. Okay, if you just have the Y part, you don't have the X part, it's going to be a special line, it's going to be horizontal. So it's going to be, make sure it's dashed. So it's dashed. Oh, that's a little bit hard to see. Now, it's still the same thing. I got to shade one side or the other. Well, since it's greater than, which side do I shade? Above it or below it? Greater than is always above. Okay, so you're going to shade above. So Y is greater than 1, shade above it.
Shading coordinate planes.
My favorite. All right. Part B. x is less than or equal to -2. X is less than or equal to -2. Now this is missing not the x, but it's missing the y. Now this is also a special type of line. It's not horizontal though, it's vertical. And it has to go through the number -2 on the x-axis. Since it's greater than or equal to, it's going to be a solid line. So we got a solid line. And since it's less than, we shade below. All right, did anybody say, well, where's below at? Okay.
I was just about to say that.
So where's below at? Right, you got a vertical line. There's really no above or below. So here's where you got to use your common sense. Christian had a little bit there. If it's less than, you want to go to where the smaller numbers are. And so the smaller numbers are going to be to the left. This is the only time where you don't have an above or a below. You got a left or a right. It's a vertical line. So less than would be to the left.
Oh, yeah, I'm smart. Imagine that.
Okay. And above would be to the right. Okay. Did you want to go to where the smaller numbers are?
No homework. I'll bribe you.
Got it. All right. Now this last little thing here, you come up with the inequality. You should be able to come up with this. Take a look at that. What inequality is represented by that graph? Okay, so you need to know the y-intercept, you need to know the slope, and we need to know above or below. So here, I'm going to at least highlight a couple points. This point here is on the line, and this point here is on the line. Okay, the other ones are close, but not exactly. So use those 2 points. Now, we're going to start with y. Is it going to be greater than or equal to, less than, or less than or equal to? Christian?
Greater than. Or
Since it's shaded above and it's a dashed line, it's just greater than. What is the slope of that line? I got to go up how far? 1, 2, 3, and over 4. So it's greater than 3/4 x plus 1 because that's the y-intercept. All right, take a look at part B. See if you can figure out what part B is. See if you can figure out what part B is. Yeah. So you get that. Yeah, we got. Better than that, that's good. Better than that, that's good. Jay, any ideas on part B? No idea?
I have an idea.
What's, you got an idea, Christian? What do you think? I'll start you off. Why?
Yeah, y is less than 1x. That's as far as I got.
Hey, he's really close. Josh?
Plus 0. 0.
Plus 0. It's still one little thing missing.
It's -x.
The slope is a negative slope.
Shoot.
Now, you can put the plus 0 in there. Not necessary. You can just write it's less than. That's fine. Okay?
So, no homework.
Oh, I gotta be a little bit.
It's too hard. Can you take off at least 6 problems?
1, 2, 3, 4, 5, 6. There's only 8.
So, that's a lot.
First day back.
First day back, we're giving us 10 questions on our homework. That's a little negative. You gotta go straight in your bag. First day back, we already have 10 problems.
It's just little fun. I'm gonna take them out.